So hello guys, good afternoon to all of you. Let's start the discussion of the mock test 2. Okay, I hope my audio and video is clear. So let's start the discussion without wasting the time. So first of all, what is given in the question number 1? Actually, this question belongs to the gravitation chapter, and in the question it is asked that a satellite is projected with a speed that is given at under root 5 GME upon 2 RE from a distance 2 RE from the center of Earth along radially outward direction. We have to find out the speed of satellite when it reach very far from the Earth. Okay, here it is given that m is the mass of Earth and RE the radius of the Earth. But what is the concept? We know that this is the concept. Simply we can say that conservation of mechanical energy we just apply and we can find out the speed. Actually, if we consider that this is our earth surface, if this is our earth surface and it is given that a satellite that is projected from a distance to RE. Okay, so if this is distance RE, so we can say this distance we can say that is the 2 RE. Okay, here we project a satellite radially outward directions. We can say this is the required velocity, that we can say this is the velocity. Okay, फिर क्या बोला है क्वेश्चन में कि the velocity that is given to the satellite at under root 5 GME upon 2 RE. Okay, and it is saying that if the find out the speed of satellite when it reach very far from the earth. What is the meaning of very far? We can assume that it reach at the infinity. Okay, if it reach beyond the gravitational field of Earth, so we can say that here the final potential energy at U2 will become zero because there is no interaction. But if we look the data, whatever velocity given to satellite, that is greater than the escape velocity, right? Under root 5 by 2. Here we know that here this v is nothing but this is greater than escape velocity. The escape velocity at Earth's surface, that is nothing but under root 2 GME upon RE. And here 5 by 2 is given. So we can see that this data is given greater than the escape velocity that for the satellite at Earth's surface. Okay, it means it must having some energy extra, some kinetic energy extra as compared to its escape velocity. It means it must possess some kinetic energy at far away point from the Earth. So we must say at this point it must possess some kinetic energy. How we can recognize this? Because on the basis of the concept, this v is greater than escape velocity. Okay, so if we apply the concept of, what is the concept? That conservation of mechanical energy. Conservation of mechanical energy. So according to conservation of mechanical energy, we can write down here, beta. What we can write down here? That K initial plus U initial equal to K final plus U final. We know that K initial, that is nothing but half m. If we consider the mass of satellite is small m, half m v square. Here velocity is given that 5 GME upon 2 RE. So if we square the velocity, this will become in this. What is the potential energy? Potential energy because of the interaction, and we know that potential energy written as G minus times G M1 M2 upon R. So what is the potential? Minus times G mass of Earth into mass of satellite into distance between them. What is the distance center to center distance? That is the 2 RE. So write down 2 RE here. K final. Sometimes the student definitely make a mistakes and assume that at infinity velocity will zero. We can't write down here because we have to understand the velocity that is greater than escape velocity. So this is not a minimum velocity. It means satellite must possess some kinetic energy at far away point. Okay, that's why we can say we have to write down here half mv square. We have to find out v here. What is the final potential energy? G M1 M2 upon R. If you put the value R infinity, this will become 0. Okay. So if we see here ki m small m is cancel out, and here what is the value of b? If we solve this, we can easily say that ki this b will become nothing but 3gme upon 2re. Okay. So which option is the correct one? Option B is the right one. I hope this is clear. Okay. So this type of question we have to do a lot of practice for such type of question beta, because the question in the gravitation chapter that is directly asked from the fundamental of the orbital velocity, escape velocity, and the Kepler's law. Okay, let's move for the next. This question number 2, here it is saying that a square loop is given, another circular loop is given, and the concentrically, it means concentric, it means the center of the square that is coincide with the center of the circular loop. Okay, current in square loop is I1. It is saying in the diagram also, okay, the current is square loop is I1 and I2 is opposite sense. So what is the ratio of I1 upon I2 such that magnetic field at center is 0? So first of all, if we know the formula, what is the magnetic field due to current carrying coil at the center, what is the magnetic field due to square loop at the center, then we will get the answer of this question. Okay, and two loops are insulated from each other. It means we can say that the two current don't interact to each other. Okay, so if we assume that if we firstly consider the square loop, and in square loop, what is the current is given beta? The current is I1, and the sense of current we can see here, that is anti-clockwise direction. So what is the direction of field here? We can say if we consider the field due to this current, that is V1. Okay, and we know that if there is one finite wire and we want to find out the field at center, we know the formula of the field due to straight wire. And we know the concept, sir, if finite wire makes θ1 angle from here, θ2 angle from here, then we can write down the formula mu naught upon 4 pi r sin θ1 plus sin θ2. I hope this is clear for everyone. Mu naught I upon 4 pi r sin θ1 plus sin θ2. Here we can say if this is square of θ1 and θ2 is equal to 45 degrees. If we put the value, so we can say mu naught, okay, and what is the current? That is the I, okay, divide over 4 pi, this distance is equal to radius. This distance is nothing but equal to radius 4 pi r. Sin 45, 1 by root 2. Again sin 45, 1 by root 2. This will become 2 by root 2. And 2 by root 2 is nothing but root 2. This is the magnetic field due to one straight wire. And we know that in square, the similar type of 4 straight wire is present. Then what is the B net? What is the B1 net? So B1 net is nothing but, and both due to each and every finite wire, the magnetic field direction is same. Okay, and that is nothing but outward to plane of paper. So we want to find out due to R 4 wires, then we have to multiply by 4 here, and the result will become mu naught I upon 4 pi r into root 2. And direction for the outward to plane of paper, we consider a dot here. So what is the V1 net beta? V1 net is nothing but 4 and 4 is the cancel out here. Mu naught I root 2, and we can say here this is pi into r. Okay, say this is the equation number 1. And the same time, if you want to write down the formula of magnetic field at center due to circular loop, so what is the formula? Say this is the V2, that mu naught I upon 2r. Okay, beta, we must remember the formula, because in the magnetic section the question is directly asked from the formula. Here we have to find out the value of I1 upon I2, so that net field at center is 0. What is the net field at center is 0? We can say the V1 must be equal to V2. That means B net equal to 0. B net is nothing but that B1 vector plus B2 vector. I hope this is clear. And for B net equal to 0, the magnitude of B1 vector must be equal to B2 vector. Here if we see the sense of that is inward. Okay, so that is the inward to plane of paper. So we can see here, if we equate these two values, so this is nothing but mu naught I, the current in square loop is I1, the current in circular loop is I2. So mu naught I1 root 2 divide over pi r equal to mu naught that we can say I2 divide over 2r. Okay. Here we can say what is the ratio if we want to find out the ratio that I1 upon I2. So I1 upon I2 is nothing but beta. We can say here this will become I1 upon I2. We can write down here. And the I1 upon I2 will happen here. I1 upon I2, this will equal to pi upon 2 root 2. Okay. I think this is clear to everyone how we can write down the value of I1 upon I2. And the option is C. That is the correct answer. So such type of question, we have to practice a lot. What is the formula when we have to apply and see the direction, how we can find out the value. Okay. Again, this is the tricky problem. That is the below average problem. What is given here? A wave is traveling in the leftward direction. We have to comment over the velocity and acceleration of the particle. Okay, beta. We have to understand in the wave, there are multiple particles that performing SHM. Okay, and the amplitude of the each particles is same. There it is given that say this is the particle A. This is also performing SHM. And this is the main position. So we can say particle A performing SHM in vertical direction. Okay. And B is traveling in the negative x direction. So beta, we have to know one formula must be velocity of particle is given that minus times of velocity of wave into dy upon dx. What is the dy upon dx? X is the position of the particle, where x is the position of the particle and y is the, we can say that the direction of displacement of particle. So how we can comment the direction of velocity of the particle? Firstly, we have to find out the slope. If we want to find out velocity at point A, so what is the slope here? If we draw a tangent here, we can say the tangent makes obtuse angle. So we can say the value of this slope will become negative. Okay. What is the velocity of wave in this diagram? That is also negative. So negative and negative, positive, and this again negative. So we can say here velocity of particle is negative. If velocity of particle is negative, what is the meaning of this? What is meaning of this? The particle is moving away from the main position, that downward direction. It means this particle is moving in this way. Okay. And one thing we also know that in the SHM, if particle is performing SHM in vertical direction, then the acceleration is always acting toward the main position. Then which option is correct? We can say velocity of particle is towards the stream position because this is the stream position. Okay. And acceleration is toward the main position. I hope this is clear. How we can going to choose option D? Because of the in SHM, we can check the velocity of particle from this equation after seeing the slope of diagram. Suppose that if we want to find out the velocity of particle at this point B, then what is the answer? We can say here at this point, if we draw a tangent for finding the value of dy by dx, this value will become positive because this makes acute angle. So this will become positive here, and velocity of wave is negative, and one negative is also given in the formula. So this will positive. So whole term will become positive. So we can say velocity of particle is positive here. So particle is moving away from the main position, that in upward direction. I hope this is clear. Okay, beta. So in this way, we can make sense. The next question that we asked from the rotation chapter here, the circular disc of the radius r thickness that r by 6 is given. Okay. And the moment of inertia that I about an axis. So guys, if we consider the disk, suppose this is our disk. If we consider the disk, okay, and say this is the axis passing through center of mass of the disk. The radius of disk that is given r, and the thickness of disk is also given. And what is the thickness of disk is given? That r by 6. Okay. So what is the moment of inertia of disk about the center of mass, axis passing through center of mass? So we can say that, sir, we know the formula and we also remember all the formula of the moment of inertia. So what is the formula, beta? That if the mass of disk is m, so this formula will become mr square by 2. I hope this is clear. And again, it is saying that question, if it is melted and casted into solid sphere, then what is conserved here? That we can say if one thing is made and form and some another shape of object, then volume is always remain same because mass is always remain same because quantity is always remain same. So we can say here so mass is conserved here, and we can say कि mass is conserved that m1 equal to m2. What is the m1 beta density into volume? What is the volume? V1. What is the density? That V2. Okay. So rho and rho is cancel out. So we can say V1 equal to V2 here. Okay. First of all, we have to find out what is the volume. That initially it is the disk. Finally, it is converted into solid sphere. Okay. And we don't know what is the radius of solid sphere. Okay. So what is the radius of this solid sphere? If we consider that, suppose this is the small r. Okay. So we know that the volume is conserved here. So what is the volume in this case? We can say volume is nothing but if we want to write down that pi r square, that is the area into thickness. What is the thickness beta? That r by 6. Okay. What is the volume of sphere beta? We can say 4 by 3 pi r cube. Let us assume that the radius of that solid sphere, that is small r. Okay. So here pi and pi cancel out, and if we solve this, this will equal to r cube equal to r cube upon 8. Okay. R cube upon 8. So what is the radius here? We can say the radius is nothing but r by 2. The radius is nothing but r by 2. So what is the moment of inertia about the dielectric axis of this solid sphere? Okay, so we can say this is the I dash. What is the moment of inertia about the diameter? Sir, this is the 3D body, and the moment of inertia about the axis passing through diameter in the all three directions x, y, z, that is remain same. So we can say 2 by 5 m r square. I hope this is clear. Okay, 2 by 5 because mass is same. Mass is conserved here. Put down mass. What is the radius? That we can say r square, and 2 square, that is nothing but 4. Okay. And we already know that mr square upon 2 is nothing but that is the moment of inertia of this. So if we arrange the term from here, this will become beta mr square, and if we cancel out here, so this will become mr square by 2 into I. Okay, what is the mr square by 2 beta? That is the I. So this answer will become I upon 5. That option is the right one. Okay, so how we can use the concept of the conservation of mass? By default, we can imply the conservation of volume and then apply the concept of the moment of inertia. This is again very tricky problem. In this question, what is given? What is the relationship between the pressure of gas and average translational kinetic energy per unit volume E for a diatomic gas? Okay, beta. What happens in such type of problem, beta? Ki generally, student not read the problem carefully and they put the answer whatever they learn. Okay, here we have to very carefully see the word translational kinetic energy. Okay, so whenever we want to write down what is the total internal energy of a molecule of a gas for n mole of gas, how we can write down? So if we remember the formula, this is known as the internal energy, and here the internal energy represented by E. And what is the formula? N F by 2 RT. I hope this is clear for everyone. Okay. And we have to remember that there is n is the number of mole, F is the degree of freedom, and R is the universal gas constant. Okay, sir. Sir, tell me one thing. If this relation is applicable for ideal gas, then we can also use PV equal to nRT. Why not? Okay. Sir, here it is given for the diatomic gas, and here we have to only consider the translational kinetic energy. So we know that there are total 5 degrees of freedom in the case of the diatomic molecules, where 3 is due to translational motion and 2 is due to rotational motion. And it is asked only for the translational kinetic energy. Then we can say that the degree of freedom due to translational motion that will equal to 3, and we have to only consider 3 degree of freedom because it is mentioned in the problem the energy E due to only translational kinetic energy. Okay, sir. If we put this value here, we can say this will become 3 by 2 nRT. Sir, nRT can be replaced by PV. Why not? So we can say 3 by 2. This will become PV. So what is energy per unit volume? This is nothing but beta. We have said that this is E upon V. Okay, so this is the E dash, and E dash we can say here E dash upon V. This can be written as E. Okay, because here energy per unit volume is given. Okay, So this E equal to 3 by 2 P. Okay. So what is the value of P? We can write down here that 2E upon 3. Which option is correct? Option D is the right one. I hope this is clear to everyone. What is the basic concept that we have to understand? One is this formula, that energy and internal energy formula. Okay, here energy per unit volume. So we have to divide over volume also. Okay, let's move further next. Again, that is the formula that is the based on the radioactivity sample. The mean life of radioactivity is T naught. Okay, and we have to find out what fraction of sample remains left after the time T naught ln2. Okay, beta. But in such type of problem, there is no need to be panic, because the data is always set in such a manner so that we can easily calculate. Okay. So what is the mean life? We have to remember this formula also. What is the mean life in the radioactive sample case? The mean life or average life that is given is T naught, and this is always written at 1 upon lambda here. Okay, sir. So this is 1 upon lambda. And what is the lambda beta? How lambda can be written? Okay. So we can say that lambda can be also written as ln2 divide over T half. Okay. So if we put this value here, so what is T naught here, beta? If we put this value here, 1 upon lambda. So we can say that if we put this value here, this will equal to ln2 T half. Okay. And T half we can multiply here. So here we can say that T half that can be written as T naught ln2. Okay, what is this beta? T half is equal to T naught ln2. It means this time is nothing but this is the half life of period. This is half life of period is given. If this is half life of period, then what is the meaning of this? The half of sample is dissociated. Okay, so what is the answer here? If half of the sample that is the decade, so what is the remaining portion? That is the half. What is the fraction here? That 1 by 2. I hope we can understand, because we have to understand what is the half-life period, that half amount is dissociated that decade. Okay. So on the basis of that similarity, we can say that this time is the peculiar time where the sample is dissociated that half of its amount. Okay. Let's move for the next question. Again, this question is the property of fluid that is based on the capillary tube. Okay, we know that what is the capillary tube? That the small diameter tube. Okay, when this tube is placed inside the liquid, then what will happen? We know that there is rise and fall of the water is occur. Okay, and we know that how we can derive the formula in the case of the capillary tube. The weight of the liquid in the column of the tube that balanced by the surface tension force. I hope this is clear. Okay. So here in this column, if we consider that the radius of tube is r, and here the mg is in this column is acting in downward direction. So mg must be balanced by some another force, and this force is provided by the component of the surface tension. Okay. And what is the surface tension force? If we consider the contact angle theta here, so we can say this can be written as 2 pi. If we radius, initially radius is given beta in the problem, that radius is given, consider that r. Okay, so 2 pi r into t into cos theta. I hope this is clear. Okay, because the surface tension force acting all the periphery. Okay, and surface tension force is nothing but surface tension into length. That's why we can write down here. If we consider if this angle is contact angle theta, and if we take component t cos theta into 2 pi r. Okay, sir. If we reduce the radius, that is half of original value, then theta is not going to be changed, because this is the contact angle. Surface tension is also remain constant. Then what is the mass here? Consider that mass is m dash. Okay. So here by equation 1 and 2, what we observe here beta, the m dash is nothing but original mass by 2. Okay. So what we can say here, if the radius is half, then amount of mass is also will remain half. Which option is correct? Option B is the right one. In such type of question beta, if in the perspective of JEE examination, there is no need to solve. Just use some basic fundamentals such as unit and dimension. Sometimes we can also apply this concept. If you want to solve, you can solve by using the dimensional analysis. The time period that is depend upon the oscillation, time period of oscillation of liquid drop depend upon surface tension. Suppose that surface tension raised to power A, radius raised to power B, density raised to power C. Then we incorporate a constant here, that S is a constant, and what we have to do next, we have to write down the dimension both the side, then find out the value of A and B, A, B, C by using the dimensional analysis, then put the value and we will get right answer. This is the exact procedure. But in particular problem, we can do this question by another approach. What is the another approach? By checking their dimension. We know that the left side, that is time period. We can say what is the dimension of time period? That we can say that is nothing but t. That is unit is second. So in right side, this must equal to second. If any formula is given, then the dimension of left hand side must be equal to right hand side. K, that is the constant, dimensionless constant. So let us check with the first option. What is the dimension of R cube? We can say, if we check in RHS, so what we can say, this is nothing but this is L cube. What is the dimension of density? ML minus 3. Okay, sir. What is the surface tension? Surface tension force that can be defined at beta, force upon length, force per unit length. Force is nothing but MLT minus 2, and this is L. So this will become MT minus 2. MT minus 2. Okay, sir. MT minus 2. If we solve this beta, this will go away. M is cancel out, and this will nothing but under root T square. What is the dimension? T. Okay, it means this formula is the correct. Okay, and we can also eliminate B, C, D option because the same parameters placed in numerator and denominator. So we can adjust. We can see if this answer is possible. So B, C, D is not possible here. I hope this approach is helpful, and believe me, 1 to 2 questions we can easily solve by using this technology. Okay, let's move for the next. Here again, this question that is asked, as we discussed in the crash course, beta such type of question that is the conservation of mole, conservation of energy, too much important in the perspective of the kinetic theory of gases and the gaseous state chemistry also. Okay, what is given? Two identical container. Okay, to consider this is the container one. Okay, and join with a pipe. Okay, this is another container. Okay, suppose the volume each container we consider that the V naught. Okay, and joined by a pipe. Container contains identical gas that T naught, pressure P naught. Okay, sir. One container is heated to 2 T naught. Okay, if one container is heated to 2 T naught, then what is the and another is maintaining at the same temperature. Okay, this is the final condition, and this is the initial condition. This is the final condition beta. We have to find out the final pressure. So what will happen? If chamber is closed, we can say initial number of mole of total gas is equal to final number of moles. If we apply the conservation of mole, okay beta, if we apply here that conservation of mole, so what is according to conservation of mole beta? N1 plus N2 at initial condition must be equal to number of mole at final condition. Sir, by using PV equal to nRT, can we find out number of mole? Yes, sir. PV upon RT. Can we put the value here? Yes, sir. P naught V naught divide over RT naught. P naught V naught. What is the? See here. What is the initial number of mole for container 2? That is RT naught. Okay. For this is for the final condition. What is the number of mole here? What is the pressure? We don't know, sir. If we consider the final pressure of gas into container become P. Okay. What is the volume? That will be naught. R. What is the temperature beta? That is the 2T naught. Here, if we solve this, what will happen? P naught, V naught, and the second container will remain same at the T naught temperature. Okay, sir. RT naught is gone away. V naught, that is the cancel out. So what we can solve here, beta? What is the pressure we can see here? This value will become 2P naught. And if we solve this, so this will become This will become beta 3p by 2. 3p by 2. Okay. And what is value of p here? That 4 by 3 p naught. So I hope option C is the correct. Beta, always remember such type of fundamental. One is the internal energy will remain constant and equal to constituent particles. Okay, I hope this is clear. And in previous course, we already discussed how we can apply the concept. Okay, let's move for the next question, beta. Again, the question is asked in the Young double-slit experiment. I hope this question is solved by everybody. Okay, what is given here, beta? It is given that in Young double-slit experiment, the fringe width is beta. Okay, first of all, we have to understand what is the fringe width, what is the formula, sir, d lambda upon small d. This is the two slit is given, this is the screen is given, and this is the gap between two slit small d, and this is the distance of slit from the screen, that is the capital D, and this is the position where slit is formed, that is the y. I hope this is clear for everyone, beta, and we know the concept how we can apply here. Okay, beta? Yes या no, beta? ठीक है. Let's move for the next. Sir, it is given that the intensity at point distance y is beta y4. Okay, here we have to take in y beta y4 from the central maxima, and the maximum intensity at center maxima, that is the I naught. What is the intensity? If the intensity passing through both the slit is, if we consider same, then what is the formula, beta? That 4I naught, we know that the formula, that is the cos square phi by 2. This is the intensity at center point, but it is given that I naught. So we can say, suppose this value is not I naught, say this is the I1. Okay, so this is 4I1, and this value is given that is at center point, we can say phi equal to 0 here. This value is equal to I naught. Okay, sir. So we have to remember this here. For I1, we can put I naught here. And if we apply the formula that phase difference equal to 2 pi upon lambda into path difference, how we can write down the beta path difference? देखो बेटा कैसे मैं लिख रहा हूँ, आप दूसरी तरीके से लिखने की कोशिश करना. मुझे पता होता है बेटा जी कि यहाँ पे ये वाला एंगल थीटा है, जब सब कुछ स्मॉल है तो ये वाला एंगल थीटा है, ये वाला एंगल थीटा है. तो मुझे पता रहता है बेटा कि मैं डेल्टा एक्स को क्या बोलता हूँ बेटा, पाथ डिफरेंस. डेल्टा एक्स को क्या बोलता हूँ बेटा जी, पाथ डिफरेंस. और डेल्टा एक्स को मैं डी साइन थीटा लिख देता हूँ. सुनना मेरी बात को ध्यान से. डेल्टा एक्स को डी साइन थीटा वी कैन राइट. सर जब थीटा बहुत छोटा है तो मैं इसको टेन थीटा भी लिख सकता हूँ, व्हाई नॉट. एंड सर टेन थीटा को मैं यहाँ से क्या लिख सकता हूँ, इस ट्रायंगल से परपेंडिकुलर अपॉन बेस. दिस कैन बी रिटन एज डी वाई अपॉन कैपिटल डी. क्या ये बात समझ में आई बेटा? इसका मतलब मैं डेल्टा एक्स की जगह क्या लिख दूंगा बेटा, डी वाई अपॉन कैपिटल डी. आई होप दिस इज क्लियर. दिस विल बिकम 2 पाई अपॉन लैम्डा. बस इतनी चीज याद रखो, आपका काम हमेशा हो जाएगा. ऑलवेज बिलीव मी. 2 पाई अपॉन लैम्डा डी. वाई की वैल्यू कितना रखें बेटा, बीटा वाई 4. बीटा की वैल्यू डी लैम्डा अपॉन स्मॉल डी. डी लैम्डा अपॉन स्मॉल डी इनटू कैपिटल डी. देखो स्मॉल डी कैपिटल डी कैंसिल आउट. Okay, here beta y4, so we have to put 4 here also. Okay, and lambda is lambda, cancel out, so this will become beta pi by 2. Okay, it means beta y4 distance पे phase difference कितना होगा, pi by 2. Okay, let's use the formula beta. What is the formula that we can use here? See in this slide, we know that the formula, our formula equal to I at general point. What we can write down, I maximum, which means I at center, and cos square phi by 2. Okay, what is the I maximum? Sir, that is the I not given in the problem. Cos square phi is pi by, pi is nothing but pi by 2. This will become pi by 4. Pi by 4 means beta, this will become 1 by root 2 square, that 1 by 2. So what is our answer beta? I naught by 2. I hope this is clear. Okay, such type of tricky question. This is, I think, this is the game changer for this question. डेल्टा एक्स को आप किस तरीके से कनेक्ट करते हो, ये डिपेंड करता है कि आप किस तरीके से फार्मूले को याद किए हो, फार्मूले को लर्न किए हो. वन थिंग मोर बेटा, इन रे ऑप्टिक्स एंड वेव ऑप्टिक्स डायग्राम आपके माइंड में जरूर होना चाहिए. कि डायग्राम कैसे हो रहा है, कि सपोज सिंपल माइक्रोस्कोप, कंपाउंड माइक्रोस्कोप, तो वो थॉट प्रोसेस अगर रहेगा तो क्वेश्चन ऑलवेज बनेगा, कभी गलत नहीं होगा. आई होप ऑलरेडी डन दिस प्रॉब्लम. Again, this is the very beautiful problem. We can say this paper is the quite easy as compared to previous one. Okay. बेटा पूछा है कि सपोज डेट की अगर मेरे पास ये कोई लूप है, इसमें इलेक्ट्रॉन रिवॉल्व कर रहा है, सपोज डेट की इलेक्ट्रॉन रिवॉल्व कर रहा है इन दिस सेंस, तो व्हाट इज द डायरेक्शन ऑफ करंट इन दिस सेंस. बेटा कोई मुझे बताए व्हाट इज द वैल्यू ऑफ मैग्नेटिक फील्ड एट सेंटर. व्हाट इज द वैल्यू ऑफ मैग्नेटिक फील्ड? एनीबडी write down in the comment box what is the magnetic field in center. Beta if this radius is small r, sir, mu naught I upon 2r. If number of turn is not given, then we can consider the number of turn is 1. Okay sir, but this formula I is not given in any option, then what we have to do? Sir, we know that ki I is nothing but I is charge per unit current. Okay, so how we can write down the current? That charge, magnitude of charge divided over time. I hope this is clear. See the answer. If any option match with this, no sir, because time is not given in any option, then we have to replace time also. How we can write down the time beta? Because we know that time is also written as beta 2 pi upon omega. I hope this is clear. We know that time is written as 2 pi upon omega. Omega is the angular frequency or angular velocity, and 2 pi means वन राउंड में कितना एंगल कैलकुलेट हुआ. दिस विल बिकम 2 पाई अपॉन ओमेगा. सी एनी ऑप्शन मैच विद दिस? नो सर, बिकॉज ऑप्शन इज बी इज गिवन दैट बी इज द ऑर्बिटल स्पीड. देन व्हाट वी हैव टू डू इन नेक्स्ट? बेटा वी हैव टू आल्सो कन्वर्ट ओमेगा इन द फॉर्म ऑफ velocity, that is the linear velocity. Sir, if there is any formula? Yes sir, in circular motion v equal to r omega. We can put the omega here, v by r. Okay, see here what will happen beta, mu naught ev divide over this will become 4 pi r square. I hope this is clear. Option C is the right one. Okay beta, so how we can proceed? Beta one more thing we have to mentally prepare. In such type of question we also ask what is the angular momentum. What is the angular momentum? So we have say mbr. Okay, I hope you can compare with, you can also calculate what is the ratio of their frequency. Okay, in particular some other radius, that suppose that in 2r radius if current is flowing, so we have to mentally prepare such type of question. Okay, let's move for the next question. Here the thermal coefficient. Again, this is the beautiful problem. Okay beta, why beautiful? Because that is something different. Okay, suppose that this is the rod. Okay, suppose the length of rod is L. If we increase the temperature, we can say thermal expansion is occur and the length of rod is increases. So if we increase the dt temperature, then what is the length of rod? Say this is dl. So how we can write down that dl can be written as beta alpha dt. I hope everybody know about this formula. Yes, give me thumbs up if you know such type of formula. Ki sir, on small increase of temperature we can write down the change in length. But here there is one very specific point is given ki alpha is function of time. It means alpha vary with time. So if we put value alpha here, that 1.6 into 10 raised to power minus 6 into t into dt. Then what we have to see here beta? Initial 0 degree Celsius length is 10 meter. Then what is the change in length in mm if we increase the temperature 25 degrees Celsius? So this is the small length. We have to calculate large length. Then what we have to do? We have to integrate. Okay, what is the initial change in length? That is the 10. Okay, say initial change in length, that is the 0 at 0 degree Celsius, and final we can say that is the delta L. Okay, and what is the final temperature? 25 degrees Celsius. What is the integration here? Delta L 1.6 into 10 raised to power minus 6. The integration of t dt t square by 2. If we put the value t square by 2, what is the limit? 0 to 25. Okay, so this will become 1.6 into 10 raised to power 6. This will become 625 divided over 2. So final answer, it is asked in mm. This is in meter. So what we have to multiply by 1000. If we solve this, we will get a required answer, and I hope the answer is nothing but 5 mm. Okay, so chat in comment box beta ki I hope 5 mm, that is the change in length. If it is problem that tell the final length, then what is the answer? Original length is 10 meter, that final length will become 10 plus 0.005. I hope this is clear, beta. Okay, so we have to understand what is asked in the problem and why we use integration here. Okay, let's move further. Next question. Very important beta. In such type of लिख के ले लो बेटा, इस टाइप का क्वेश्चन तो आना ही है, because this is based on the very important concept at conservation of angular momentum. और क्या बोल रहा है इस क्वेश्चन में बेटा? सपोज टू डिस्क इज गिवन हैविंग द मोमेंट ऑफ इनर्शिया. ओके सर, सपोज दिस इज द डिस्क 1. ठीक है, ओके. इसका मोमेंट ऑफ इनर्शिया I1 कितना है? 9 kg मीटर स्क्वायर. ओके. द अनदर डिस्क इज गिवन. ओके. वह है मोमेंट ऑफ इनर्शिया. इसका मोमेंट ऑफ इनर्शिया I2 इज गिवन बेटा, दैट 3 kg into मीटर स्क्वायर. ओके सर. Angular velocity omega 1 is given, that is 6 radian per second, and here omega 2 is given 10 radian per second. Okay, we can say here both are revolving in the same direction, so they are brought together gently. बेटा gently का भी बड़ा important है बेटा. यहाँ gently means कोई भी external torque नहीं आएगा, कोई भी force नहीं आएगा, बड़े प्यार से रखती है. So if we place gently, एक के ऊपर एक हमने जेंटली इस तरीके से प्लेस कर दिया, तो मोमेंट ऑफ इनर्शिया तो इंक्रीज हो गया ना बेटा, लेकिन टॉर्क तो कोई आया ही नहीं. अभी भी एक्सिस के अबाउट नेट टॉर्क 0 है, फाइनल कंडीशन में भी नेट टॉर्क 0 है. सो वी कैन अप्लाई द इनिशियल एंगुलर मोमेंटम. सो व्हाट कैन से इनिशियल डाउन दैट I1 omega 1 equal to I2 omega 2. That nothing but that 9 into 6 equal to 3 into 10 equal to what is the total I beta? That 9 plus 3, that is the 12 into omega. This will become beta 54 plus 30 divide over 12. So here we will get value of omega. Comment beta, what is the value of omega you will get here? What is the value of omega you will get here? And if we get the value of omega here, I hope everybody get the value of omega, that's 7 radian per second. Once we get the value of omega, let us remove this to avoid the confusion. Sir, what is asked? Loss in kinetic energy. So what is the loss in kinetic energy beta? We can say कि the loss in kinetic energy, मतलब kinetic energy initial minus kinetic energy final. So how we can write down? Half I1 omega 1 square, that half 9 into 6 square, plus this is also part of initial, half 3 into 10 square minus half. What is the final I beta? We can say final I will become 12 into 7 square. If we solve this beta, we will get a required answer in joule, that 18 joule. Why we put initial minus final? Because we already consider loss. Okay, 18 joule energy loss हो गई. कहाँ गई ये एनर्जी बेटा? पता नहीं सर, हीट या साउंड के फॉर्म में कहीं भी सराउंडिंग में चली गई होगी. एक क्वेश्चन और बन सकता है, अगर बोल देता कि इनिशियल टेम्परेचर सपोज एट 30 डिग्री सेल्सियस एंड इफ वी कंसीडर द हीट लॉस, the loss in kinetic energy get converted into heat, then find the final temperature or change in temperature. I hope this is clear. And the specific heat दे देता मटेरियल का और मास दे देता कंप्लीट सिस्टम का. So can you solve this? This is the further extension of such type of problems. We have to always prepare for this. I hope this is clear beta. Again, this is the question that is based on the simple observation. And what is given beta? Okay, 10 minutes remaining more. Peak, this is the truth table is given, and we have to comment that this truth table belong to which one of the correct gate. Okay, so if we see this P into Q and the operation will get the output 1. Okay, so when the operation will get result 1 beta, that 1 into 1 1, 1 plus 1 1. Okay, 1 into 0 0, 0 into 1 0, 0 into 0 0. For which gate this phenomena is happen? If we remember the concept beta in the case of AND gate beta, Say this is input A, this input B, and this output is C. So what will happen, beta? That in the case of AND gate A dot B, suppose this is the C, and the output we only get 1 when both the input having the value 1. So here we can say that in the single case we will get output 1. Otherwise, in all case, we will get 0 as a output. What is the meaning of this? This particular property belong to AND gate. Which option is correct? AND gate. I hope this is clear. That is a very easy and scoring topics. तो बेटा गेट जेई मेन में गेट जरूर पढ़ के जाना है बेटा. ओके, हाफ एन आवर्स का टॉपिक है, आप जरूर गेट पढ़ो, बिकॉज 1 से 2 क्वेश्चन तो आते ही आते हैं और आप सही करके आओगे. देयर इज नो प्रोबेबिलिटी कि आपसे ये क्वेश्चन गलत हो जाए अगर जानबूझ के नहीं गलत करोगे. डेट्स ऑल. This is the below, we can say कि above average problem, good problem बेटा. What is given here बेटा? Suppose इस ब्लॉक को अगर हम छोड़ देते तो इसकी टेंडेंसी कहाँ होती? डाउनवर्ड जाने की. तो फ्रिक्शन कहाँ लगता? ऊपर लगता. पता नहीं, शायद नहीं रुक पा रहा होगा, इसलिए एक हमने इसको बाहर से एक्सीलरेशन दिया. बाहर से एक्सीलरेशन दिया तो पहली बात तो सिस्टम इज एक्सीलरेटेड. System is accelerated. When system is accelerated, then we have to understand one thing. Whenever system is accelerated, then we directly not apply the Newton law of motion. And in this case, we can use the pseudo force. So first of all, we can say that if the acceleration is given in the leftward, then pseudo force is acting if the mass of this block is m into a in rightward direction. I hope this is clear for everyone. Okay. And it is saying that what is the maximum horizontal acceleration? See this word, highlight this word, maximum horizontal acceleration. Can we give the plane so block does not slip on the plane? Maximum means बेटा जितना ज्यादा से ज्यादा maximum acceleration हम दे सकते हैं. अगर हम इसको maximum acceleration देंगे and suppose this angle is theta, this angle also become theta, तो ma का एक component इधर आएगा that ma cos theta, और ma का एक कंपोनेंट बेटा इस डायरेक्शन में आएगा डेट इज ma sin थीटा. एंड वी आल्सो नो कि mg भी तो इधर ही है, और इफ दिस एंगल इज थीटा तो ये भी तो थीटा, तो mg का भी एक कंपोनेंट इधर आएगा डेट mg cos थीटा, और mg का एक कंपोनेंट नीचे आएगा डेट mg sin थीटा. दिस इज नथिंग बट fbd. आई होप दिस इज क्लियर. मैक्सिमम एक्सेलरेशन का मतलब ये है बेटा कि अब ब्लॉक की मूव करने की टेंडेंसी ऊपर की तरफ होगी, क्योंकि आपने अपने मैक्सिमम फोर्स को अप्लाई कर दिया है. इट मींस ब्लॉक हैविंग टेंडेंसी टू मूव इन अपवर्ड डायरेक्शन. सो इन विच डायरेक्शन फ्रिक्शन फोर्स इज एक्ट? एनीबॉडी कैन टेल मी? इफ वी find out the maximum horizontal acceleration, then we can say that the component of acceleration create net force in this direction, want to create net force. Then where is the tendency generated? In this direction body want to move. So where is the friction will come into picture? In downward direction. We know that beta static friction is the Behrupiya in nature. और ये सब कुछ बदलता है बेटा, वैल्यू तो बदलता ही बदलता है, डायरेक्शन भी बदल देता है. So in this case we can say this is ma cos theta. Okay sir. This is mg sin theta. Okay sir. Sir, in this direction the body having tendency in this direction, tendency in upward direction of motion, then friction force acting in downward direction. I hope this is clear for everyone. Okay sir, one more thing, what about the normal force beta? We can also find out the value of normal force here. How beta? If we apply the equation of motion in this direction, say this is the normal force. Okay, if this angle is theta, so this angle is also become theta. Okay, so what is this value beta? We can say here, if we want to write down the normal force here, how we can write down the normal force? See beta, very carefully. N must be balanced ma sin theta plus mg cos theta. If this is just a condition of slip, it means block is not going to slip. That is done. So if we balance the force in the along the incline, then what we can write down here beta? That friction force plus mg sin theta equal to ma cos theta. Okay, beta. How we can write down the friction force here, beta? Mu into n. Mu into n, that is the value of the friction force. What is the n, beta, here? That is nothing but ma sin theta plus mg cos theta plus mg sin theta equal to ma cos theta. Okay, sir. If we find out the value for a here, we have to transfer here. So we can say if we put a common here, this value will become, see here, beta, m, cancel out. This will become cos theta minus mu sin theta. Transfer a in right side, and this value will become m is cancel already. This will become g cos theta. Okay, g cos theta plus g sin theta. Okay, sir. If we find out the value from a here, if we put the value of a here, you will get the answer. You will get the answer. So what is happening in this case, beta? What we have to remember in such type of scenario, beta? Whenever in question, that correct answer is the 20 meter per second square. We solve this. If we solve this, we will get answer here. That is, what is the correct answer, beta? 20 meter per second square. In the suppose this case, a maximum is given. How we can learn the acceleration? A maximum, that is nothing but g sin theta plus mu cos theta divide over cos theta minus mu sin theta. Okay. If suppose in this case a minimum is given, then what is difference in the problem? If a minimum is given, then we have to change the sign here. Then we have to change the sign here, beta. So we have to remember this thing. Okay, this is nothing but mu mg here. Okay, so I hope this is clear how we can approach for the two cases. Let's move for the next question, beta. The next question that is asked for the again surface tension chapter. What is given? The force separate to glass plate area thin film. Okay. Suppose that there are two glass plates are placed in such a manner, and suppose this is liquid is filled, and we want to lift this plate, then what is the force applied here, beta? And if we consider the force here, suppose here the atmospheric pressure is F, and this is the pressure inside the curvature. Okay. So what is the pressure here? What is the pressure difference that we can write down here, beta? So we have to remember the formula. If we consider that this gap is x, if this gap is x, then what is the formula that we should remember here, beta? What is the formula we should remember here? That we have to remember the formula that delta P is nothing but T1 upon R1 plus 1 upon R2. What is this formula? If a surface having two types of radius of curvature, or in general, suppose if we consider the sphere, so in the case of sphere, both the radius of curvature, this way and this way, all equal. So R1 and R2 will become equal. So this formula will become 2T upon R for sphere. But in the case of cylinder, we can say one radius will become radius of curvature infinite. So formula become T upon R. Okay. So in this case, this formula, this is the x, the radius of curvature is equal to xy2. So this will become 2T upon x. Okay. In the place of one radius of curvature that we will consider here negligible, and we can say here ki the R1 is nothing but here xy2. What is the force, beta? If we neglect the mg here, because mass is not given here, so we have to neglect the mg. Otherwise, we have to also consider this is the force. Mg is acting downward direction if given, and the surface tension force is also acting in downward direction because of the excess pressure. So we can write down the formula that mg plus excess pressure into area. Okay, but mass is not given, so we can neglect here. What is the excess pressure? 2T upon x. What is the area given here, beta? The area is given that 100 centimeter square, so 100 into 10 raised to power minus 4. Put the value beta. What is the surface tension? 70 into 10 raised to power minus 3. The value of x that we can put here beta 0.05 centimeter. We have to convert into meter. Okay. And this value is equal to 10 raised to power minus 2. So if we solve this value, we will get answer. And what is the correct answer beta in this case? If we solve this, we will get correct answer in nothing but 2.8 Newton. I hope this is clear to everyone. What is the concept? That is the general formula. We should remember this formula. Okay. What is the new question asked? For the cylindrical bubble. If there is the bubble is given, suppose soap bubble, then we have to multiply by 2 here because 2 interfaces generated. But the cylindrical, suppose the is instead of spherical, if this is the cylindrical, then we have to consider only T by R here. Okay, because one radius of curvature will become infinite. Let's move for the next question. Again, this is the easy problem for the Doppler effect. And I hope in Doppler effect, we know how we can apply the formula that the apparent frequency that can be written as F naught. Here, if we consider the velocity of sound, that is the C plus minus velocity of observer, C plus minus velocity of source. If source is coming toward the observer, then what is given here? Initial condition, observer is stationary, so observer velocity is 0, okay, and the apparent speed frequency at the 1000 hertz. Put the value 1000 equal to F naught. C that can be given 350, okay, and again this will become 350 because source is coming toward the observer. This is the situation. Source is coming toward the observer. It means if we want to maximize this thing, so we have to minimize this thing, then we have to put a negative sign here. And what will happen here? Minus 50. So here we will get value of F naught, and that is nothing but 6,000 upon 7. Again, when source is moving in this way, then what will this formula will happen? Then we can say this will become F apparent, and F naught is nothing but 6,000 upon 7. And here again we can apply. In this case, in the second case, the source is moving away from the observer. So what will happen? 350, and if source is moving away, then apparent frequency will decrease. So how we can decrease the value? If we put plus sign here, this will become 350 upon 50. And if we solve this, and we will get the answer, I think 750 hertz. So what is the answer in this case? 750 hertz. Let's move for the next question. Again, that is the easy problem that is asked from the electrostatic section. It is saying that at this point total field is 0. So this is given that the negative charge, it means this want to attract because of this electric field in this direction, say E1, and because of the cell, the electric field in this direction E2. If net field is 0, so E1 must be equal to E2 in magnitude. Correct है sir? Sir, E1 की value कितनी लिखेंगे? We know that कि outside the cell, cylinder, solid, hollow, कुछ भी हो, KQ by R square. So what is the KQ? Suppose that the charge is small q and the distance from this center to point P, this will become 3R by 2. This will equal to 9R square into 4. What is due to cell at point P? Electric field. The distance from this center to this center, that will become 2R. This distance will become, we can say 2R, that is already given in the problem. So this will become KQ upon 4R square. Okay, sir. K cancel out, R square cancel out, and Q is also given, that is 9 coulomb. Because direction already we considered, so don't put minus sign here. So this will become 4 upon 9 into 4. This is the value of Q. And I hope the value of Q is nothing but 6 coulomb. Okay, so what is the answer? 6 coulomb with the right answer. Again, this is the question that is asked on the Bristol law. It is saying that a light is incident and there is suppose that this is the normal and ray is reflected back and the 100% light is polarized. Okay. So this angle is I, this angle is R, and we know that in the Bristol law, the refracted and reflected ray at 90 degree. I hope this is clear. Okay. Okay, beta. So what is the Bristol law? So using Bristol law, we can write down beta. What we can write down here? We know that ki one thing beta, in the Brewster angle. What is the Brewster angle beta? Anybody can you tell me what is the Brewster angle? So you can say that ki Brewster angle that time IB equal to mu. Okay, and mu is given 4/3. Okay, it means tan IB is nothing but this angle is in a right angle triangle that is given 53 degree. This is nothing but 53 degree. Okay. So I hope this is clear. If IB is 53, then what is value of R here? So we can say that 90 minus 53 that will equal to 37 degree. So I think this is helpful. Whatever important question that I feel I will discuss in next slide also. So you just remember the concept and do a lot of practice. So thank you so